Hello and welcome to the lecture session on inverse Laplace transforms. In this video, I am going to discuss about the applications of Laplace transforms to solve the first and second order differential equations. So what are the applications here and what are the formula which we are going to use here? So in this one, L of y dash of t can be written as s into L of y of t minus y of 0. And L of y double dash of t can be written as s square L of y of t minus s into y of 0 minus y dash 0. L of y triple dash of t can be written as s cube L of y of t minus s square y of 0 minus s y dash 0 minus y double dash of 0 and so on. So this is the important formulae which we need to remember while solving the differential equations. First problem. Solve by using the Laplace transforms d square y by dt square plus 4y is equals to 0 given the condition y of 0 is 2 and y dash of 0 is 0. So let us consider in terms of y double dash and y dash. So y double dash of t, the given equation is y double dash of t plus 4y of t is 0. Let us apply the Laplace transform. Then we get L of y double dash of t plus 4L of y of t is equal to 0. This is by applying the linearity property. So we know that y double dash L of y double dash can be written as s square L of y of t minus sy of 0 minus y dash of 0 plus L of y of t is equals to 0. So this L of y of t we can take common. Then this part and the first part and the last part can be merged as s squared plus 4 into L of y of t minus s into y of 0 is replaced with 2 and y dash of 0 is replaced with 0. So we get s square plus 4 into L of y of t is equal to 2s, that is s into 2 which is taken to the right hand side. Therefore, we get L of y of t is equal to 2s divided by s squared plus 4. So y of t can be equal to 2L inverse of s divided by s square plus 4. Therefore, y of t will be 2 cos 2t. Next problem. Solve by using Laplace transforms of d square y by dt square plus 3 dy by dt plus 2y equals to 0 under the conditions y of 0 equals to 1, y dash of 0 equals to 0. Let's consider the given equation y double dash of t plus 3y dash of t plus 2y of t equals to 0. Apply the formula of y double dash and y dash. So we get L of y double dash of t plus 3L y dash of t plus 2L y of t equals to 0. And we have the formula for L of y double dash of t as s square L of y of t minus sy of 0 minus y dash of 0. And for this one, 3 times of s L of y of t minus y of 0. And this one is written as it is, that is 2L of y of t. Only L of y of t terms alone is grouped together. So this term, first term and the fourth term, sixth term is grouped together. Thereby we get s square plus 3s plus 2 of L of y of t minus s into 1 because y dash of 0 is 0. Wherever y dash is there, it will be made 0. Y of 0 is 1, s of 1. And here also minus 3 is there. So that will be written. Thereby minus s minus 3, when it is taken to the right hand side, it will be s plus 3. So L of y of t will be s plus 3 divided by s squared plus 3s plus 2. Now this s squared plus 3s plus 2 can be written as s plus 1 into s plus 2. That is on factorization and simplification we get. So let us resolve them into partial fractions by taking s plus 3 by s plus 1 into s plus 2 as a by s plus 1 plus b by s plus 2. By taking the suitable values of s, we get the values of a and b. First let us take s as minus 1, then we get a equals to 2, and s as minus 2, we get b equals to minus 1. Simplify and substitute the values in this equation. We get 2 L inverse of 1 divided by s plus 1 minus L inverse of 1 divided by s plus 2. That gives us 2 into e power minus t minus e power minus 2t. Next problem. Solve by using the Laplace transforms. D square y by dt square plus 4 dy by dt plus 4y equals to e power minus t. In the previous problems, it was homogeneous. We can see the right hand side is 0. Now the right hand side is non-zero function. So given function, let us consider in terms of y double dash, that is y double dash t plus 4y dash t plus 4y of t equals to e power minus t. So apply the Laplace transform on either side. We get L of y double dash t plus 4L of y dash t plus 4L of y of t equals to L of e power t, e power minus t. So L of y double dash t is s square L of y of t minus sy dash 0 minus sy of 0 minus y dash 0 plus 4 into sl of y of t minus y of 0 plus 4L of y of t, which remains the same, and we know that L of e power minus t is 1 upon s plus 1. Now again grouping the first term, fourth term and the sixth term. Then we get s squared plus 4s plus 4 of L of y of t is equal to 1 upon s plus 1, because both y of 0 and y dash of 0 are 0 here. This term and this term will be 0. Here this term is also 0. Therefore, we get 1 upon s plus 1 into s squared plus 4s plus 4. Or we can write it as 1 upon s plus 1 into s plus 2 whole square. Now y of t is nothing but L inverse of 1 upon s plus 1 into s plus 2 whole square. Consider 1 upon s plus 1 into s plus 2 whole square and resolve them into partial fractions. So by taking 1 is equals to a times of s plus 2 whole square plus b times of s plus 1 into s plus 2 plus c times of s plus 1. By taking s value as minus 1, we get a equals to 1. By taking s value as minus 2, we get c as minus 1. By taking s value as 0, we get a b value as minus 1. Let us replace them. Then we get L inverse of 1 divided by s plus 1 minus L inverse of 1 divided by s plus 2 minus L inverse of 1 divided by s plus 1 the whole square. For the first one, it will be e power minus t, and for the second one, e power minus 2t, and for the third one, we write it as 1 upon s square, where s is tending to s plus 1. So we get e power minus t, e power minus 2t and e power minus t into t. So this is what we will be getting. It is actually s plus 2. So it is e power minus 2t into t. So taking e power minus 2t common, we get t plus 1 and this remains the same, the first term. Next problem. d square y by dt square plus 2 dy by dt minus 3y is equal to 3 sin t. Here also non-homogeneous, we can observe. The right hand side is non-zero term. Y of 0 is 0 and it is also same as y dash 0. Both are 0. So let y double dash t plus 2y dash t minus y of t is equal to sin t. So L of, applying the Laplace transform on both the sides, we get L of y double dash t plus 2L of y of t minus 3L of y of t is equals to Laplace transform of sin t. So we know that L of y double dash t is equal to s square L of y of t minus sy of 0 minus y dash 0. And 2L of y of t can be written as 2 into s L of y of t minus y of 0. And 3L of y of t remains the same. And we know that Laplace transform of sin t is 1 upon s squared plus 1. And wherever we have a y of 0 and y dash of 0, it remains as 0 because of the initial condition. Then we get only the first term, the fourth term and the sixth term. So by taking L of y of t common, we get s squared plus 2s minus 3 of L of y of t is equal to 1 upon s squared plus 1. By taking this s squared plus 2s minus 3 to the right hand side, we get L of y of t is equal to 1 upon s squared plus 2s minus 3 into s squared plus 1. Now consider this s squared plus 2s minus 3 and simplify this s plus 3 as s minus 1 and again resolve them into partial fractions. Since it is a quadratic factor, we have to assume it as as plus b divided by s squared plus 1, and this is a linear factor. We write it as c divided by s plus 3. This is also a linear factor. We write it as d divided by s minus 1. Now resolve them into partial fractions by taking the LCM and put a suitable values of s to get the value of a, b, c and d. First of all, let me put s is equals to 1 so that this term cancels, we get the value of only d, which will be 1 upon 8. Next, let us put s is equals to minus 3. Again, the first term and the last term cancels, we get the value of c, which is minus 1 upon 40. By putting s is equal to 0, we get the b value. So now in order to get the a value, we need to compare the coefficient of either s square or s or anything. So let me compare the coefficient of s cube here. So we get a plus c plus d is equals to 0. Thereby a is equals to minus c minus d, and on substituting the values of respective values of c and d, we get a as minus 1 upon 10. Now substitute the values of a, b, c, d respectively. Then the first term becomes L inverse of minus 1 by 10s minus 1 by 5 divided by s squared plus 1. And the second term becomes L inverse of minus 1 by 40. The third term will be L inverse of 1 by 8 divided by s minus 1, which on simplification we are getting, that is s divided by 1 upon 10 times of s divided by s squared plus 1. That will become a cos term, and this part will become a sin term, and again this part will be e power minus t, and because these two are linear terms, we get it as a linear term as it is. Thank you.